All right. So, hello and welcome. Thank you for joining us today. While we're still gathering a few people, I would like to start a small survey. We invite you to answer 3 questions. This is basically to get to know you a little bit better, about your career level, about sector you're involved in, and also about your relationship to the Arctic. And I hope that I gonna see a few answers coming. Right. So great. So you see the question. That's great. Yeah, our today's Arctic Passion seminar and online dialogue is dedicated to the topic of permafrost and landscape change. And before I introduce our distinguished speakers in the framework of the whole webinar, we would love to hear a bit more about you. We would like to know who's in the room today. So we invite you to write in the chat and let us know your name, your background, and maybe roughly 3 keywords. And yeah, maybe also your motivation why you're joining us today. And I'm gonna send you mine in a second. All right, great to have you all on board. For your information, this online seminar is being recorded and will be made available on the Arctic Passion and APECS websites after the event. And we are welcoming any questions you may have. You can use the chat as usual, also the Q&A box. That would be amazing. And even better, if you want to raise your hand, that would be great. We can call you on stage and let you speak. My name is Josephine Lenz. I'm your host of today's online seminar, and I'm working for the APECS Institute for Polar Marine Research in Potsdam in Germany, as well as for the Association of Polar Early Career Scientists, in short, APECS. And APECS is part of the EU Arctic Passion project. So what is APECS doing otherwise? APECS is a network from early career scientists for early career scientists from all kind of disciplines and backgrounds, and cultural, national backgrounds, with more than 5,000 members all around the world. And currently we have almost 30 national committees in 30 countries, 28 countries. APECS is a platform for exchange on various topics, may it be science communication, alternative career paths, research, of course, but also just celebration of the polar and alpine research. And education and training is a very integral part for us. As such, APECS is involved in various EU projects, of which Arctic Passion is the most recent one. And I also may highlight the Arctic Passion Sharing Circle, which was held last fall as a very special format of recent training activity. Arctic Passion itself is working on improving observation systems in the Arctic by implementing observations for societal needs. And as such, the change of permafrost landscapes is one of these so-called pilot services in Arctic Passion. And in the following, we will hear from a new service, namely a new web tool of the visualization of permafrost landscape change. And in fact, you will not only hear about permafrost change, but also fires, coastal erosion, lake drainage, and other drastic changes in the Arctic. And it is my great pleasure to welcome our 2 speakers today, Tilman Lübke and Guido Große. Tilman is an expert in maps and geoinformation and a geospatial data scientist at the APECS Institute. And Guido's background is in remote sensing as well, and he is a real permafrost expert who I myself had the pleasure to work with in the field. And he's leading the permafrost research section here at the APECS Institute and is a professor at the University of Potsdam. And with this, I hand it over to you. Tilman and Guido, the stage is yours.
Thank you very much. Hello to everybody online for this webinar today. And so we are going to talk about visualizing permafrost landscape change. And so this is part of a pilot service, and a pilot service in Arctic Passion means we have 8 pilot services in total in this project in one work package, and they are focusing on some scientific applications of data sets that are available and are produced partially in Arctic Passion or are made available through Arctic Passion. And so this pilot service focuses on permafrost. It's the pilot service 2, actually. And we have 2 components in this pilot service, and I come to that later a little bit. Before I start with that, I would like to introduce you quickly to the team here. So that's myself. Then we have Uklan Fui, who's also a professor for permafrost coastal dynamics at the University of Potsdam. And we at the Wegener Institute. Dr. Anna Irgang, she's a postdoc and senior scientist at the AWI here in Potsdam. She's working on global terrestrial network for permafrost aspects in this pilot service. Then we have Tillman, who's working on the visualization of the permafrost landscape change project, and Ingmar Nitzer, who's a postdoc also at RB, who actually worked a lot on the data set himself and developed the methods behind it. So with that, I would like to start, give a quick intro into permafrost. So permafrost is occurring mostly in the Arctic. So if you look at the map from the Northern Hemisphere, with the polar view here, you see that most of the permafrost is distributed in the high latitudes in Northern Eurasia and Siberia, in Alaska and Canada, but also in Central Asia, the high mountain areas and plateau regions there. And the colors here show the different types of permafrost extents. So the darker brownish colors are continuous permafrost, where we find permafrost pretty much everywhere in the landscape. And the farther south we go, the lighter the color gets here, and that means that permafrost gets more and more patchy. So we have holes in the permafrost, basically. It gets more and more discontinuous or sporadic. We also have a little bit of submarine permafrost in these turquoise greenish colors, which is a remnant of the former ice age terrestrial part when the sea level was much lower. What we know from observations from a large borehole network that is organized or coordinated by the IPA, the International Permafrost Association, is that permafrost is warming in pretty much all regions across the globe. And this warming is in step with the Arctic warming that we also observe. So Arctic warming, we know about Arctic amplification, the warming that is almost reaching 1.5 degrees on a global average is much stronger in the Arctic. That's what also felt in the permafrost regions. So the graph on the right shows permafrost borehole temperatures, a few examples from the high Arctic, from Nordic countries, Russia, Canada, and Alaska. So just a few examples here, but it all shows more or less steady rise over the last couple of decades. So 40 years approximately shown here. And so we see that this rise in permafrost temperatures is pretty much in step with warming. So we can use remote sensing data and modeling to track permafrost temperature rise or increases, and also the decrease in permafrost extent. And so this is an example from the ESA CCI permafrost project, a large project with many European partners, where there's a permafrost modeling component, and partially this modeling is driven by remote sensing data sets, including the land surface temperature data sets, as well as snow data sets, which are used to parameterize the model. And what this model output basically shows is a temperature increase in the high northern latitude permafrost regions in 2-meter step and in degrees Celsius per year. And so if you see the reddish colors here are about 0.2 degrees Celsius per year. If you look at it by decade, basically it's 2 degrees by decade, the warming, and it's mostly in northern Siberia, the strong warming, but other regions are warming as well. And this causes, in effect, permafrost thaw in many regions. It's not just the warming, but there's also disturbances. I come to that in a second. What you see here is very ice-rich permafrost in the northern Siberian Lena Delta. Very ice-rich permafrost we call Yeruma permafrost. So you see these bright surfaces, which are massive ice wedges from the late ice age, several tens of thousands of years old. And in between, we have frozen sediments. And these frozen sediments also contain quite a bit of organics. So these darker layers are peat layers. So permafrost can contain quite a bit of ice. By definition, permafrost is only defined by temperature. So 0 degrees Celsius for at least, or less than that, for at least 2 years in a row. And it can contain ice, but it doesn't have to. So there are many regions that don't contain ice. But if you look at the map of ice distribution across the Northern Hemisphere, we see many regions actually do contain high or medium ice content. And high and medium ice content here means at least 20% or even much more. In this particular case in Siberia, it's about 80% of ice in the ground by volume. But the other aspect is the carbon that is stored in permafrost. And what we see here is a snapshot or a zoom in of one of these layers, and what we see are grass roots sticking out there. So when this permafrost thaws along a cliff, for example, we see these old plant remnants sticking out. They're really well preserved, and that's why permafrost is a very large carbon pool. So it preserves organic matter really well. There are a number of things that happen in addition to regular thawing from the surface or active layer changes. So the general climate impacts, we see so-called disturbances, and disturbances can be very manifold, things. For example, fires in the tundra or forest regions with permafrost, river erosion, then thaw subsidence because of ice-rich permafrost and the melt of ice wedges, for example. Lake drainage we can observe in permafrost regions associated with also ice wedge degradation, for example, or erosion. We see infrastructure changes in many settlements and linear infrastructure like roads or railroads in permafrost regions, coastal erosion, thaw slumping in regions with massive ground ice, and lake expansion or lake shore erosion. So very different processes all lead to some sort of permafrost degradation, be it by thermokarst, the process that is mostly acting vertically, or thermoerosion, a process that combines mechanical and thermal thaw processes. So what does it look like thawing permafrost? Here, for example, the seasonal active layer is a very thin layer on top of permafrost, in this case also ice-rich permafrost in Siberia. Below we have perennially frozen ground, and if this is very ice-rich, like here, thawing at the coast, this is a setting in a thaw slump, means that not only the upper layer thaws, but also deeper layers can thaw. And so some of these processes are irreversible on human timescales. So we have the loss of this very old and thick ground ice that was accumulated over thousands or tens of thousands of years. We have deep thaw subsidence. You see persons for scale here, so there can be several meters or tens of meters, even in extreme cases. And this subsidence in the effect changes geomorphology, and then with that also the hydrologic systems. So runoff systems are changed, and we have the release of old carbon that is previously stored in these frozen deposits and gets released into aquatic systems or the atmosphere. So there's also infrastructure at risk. This is an example from northwestern Canada, a massive thaw slump forming next to the Dempster Highway, a very important infrastructure in this region. And so many of these regions there are underlain by massive ice bodies, and because of that, it's very hazardous for some infrastructures also. Another example from northwestern Canada, the hamlet of Tuktoyaktuk, small village at the coast and next to the Mackenzie Delta, and this is pretty much life on the edge of the Arctic Ocean, but also on the edge of permafrost stability. So what we see here is a village affected by coastal erosion dynamics, but also permafrost thaw. And so there's active planning going on for resettlement for these villages. And there are many of them in Canada, but also in northern and western Alaska. And so while these are mostly local or regional issues, there's also this global issue of the permafrost carbon pool. And recent estimates from the last couple years, or 10 years, 15 years, estimate that the northern permafrost region contains about 1,300 billion tons of carbon in surface deposits. Only about 822 of these billion tons of carbon are actually frozen in permafrost. The rest is in the active layer or in unfrozen soils. And if you compare this to the atmosphere, about 1.5 times the carbon in the atmosphere that we have in permafrost regions. And it's also almost 3 times as much as carbon as we have currently in the global vegetation carbon. So it's a significant global carbon pool. And with temperature rise that we already observe, the ground temperature rises as well in permafrost, which we observe, that causes more microbial activity and decomposition of organic matter. And these microbes produce methane or carbon dioxide, which are greenhouse gases that in turn can increase the atmospheric temperatures again. So that's a positive feedback loop. And so there are some general risks from permafrost. So it's a large region on the one hand that is affected by permafrost processes and also thaw processes now. We know that Arctic permafrost is warming rapidly and thawing in quite a few regions already. The resulting changes impact not just Arctic ecosystems, their structures and functions, but also affects communities that are increasingly threatened by permafrost thaw and coastal erosion. And because the permafrost carbon pool is very large and also vulnerable to thaw, this is of global relevance. So it's not just for people living in the Arctic, but also for us relevant. There are a few opportunities that we have from the research side, actually, to look at some of these dynamics, and that leads to the actual topic of the webinar today. So how do we better understand where is it thawing, how fast is it thawing, and what are the consequences? So there are new cutting-edge research approaches emerging, not just from field sampling, but also from automated observations and remote sensing. And so that's something that we are going to use or are using already to better understand at high resolution, both spatially and temporally, where these changes are taking place. And so hand in hand with the research, there should be community-based observations and co-production of knowledge. So it's not just we as a scientist or as a scientist produce this knowledge, but it's affecting people, and people are very interested living in these regions, of course, in what is going on because it affects their livelihood directly. So it's really important to make these connections and yeah. Okay, so coming directly to this, back to the Permafrost Service in the Arctic Passion Project, we have two objectives. So one objective is provide a global update on ground temperature and active layer trends, which are underpinned by the data from the Global Terrestrial Network for Permafrost. And that's an international network coordinated by the IPA. And so there are many international partners included in this that contribute data with their own projects, their own time. And it's an international sort of grassroots activity and should give a global picture of what is happening to permafrost temperatures. And so this will provide an update basically. And objective 2 is related directly to the maps of surface changes in permafrost thaw. And Tilman will go into detail in a bit what that actually means. So we look at thaw with high resolution remote sensing data, building on ESA and Copernicus remote sensing products, basically making some of these complex science data products available to communities, to non-scientists. And are we in time? Good. Yeah, maybe a few words about the Global Terrestrial Network for Permafrost. I mentioned already, so this is an international network that is also delivering an important parameter for the essential climate variables for the permafrost component of the Global Climate Observing System, GCOS, under the WMO, World Meteorological Organization. And two of the most important parameters are permafrost temperatures and the active layer thickness. And so what you see here on the map is a distribution of sites in the northern high latitudes, with the purple dots being active layer measurement sites, calm sites, and the red dots being the thermal state of permafrost temperature boreholes. So you see there are some clustering things there, but it's generally widely distributed in the Arctic. So as one first product that came out of the Arctic Passion Project, we have a new updated WMO guide for defining some of the standards for permafrost temperature measurements and active layer measurements for the Global Climate Observing System, for these essential climate variables that are important to monitor climate change, not just in the Arctic, but anywhere on the globe. So this has just recently been submitted to WMO with the organization from Anna Irgang and many others from the permafrost community who are involved in the Global Terrestrial Network for Permafrost. So then we know that there are quite a few people living in the Arctic. It's a thinly populated region, but nevertheless, there are many settlements there, more than 1,000 in total. About 5 million people live on permafrost ground. And that's the map on the right here, actually. And on the left, we see the Interact research stations. Interact is a large network for terrestrial research and monitoring in the Arctic. And so there are quite a few stations there, I think close to 100. And so the second component of the pilot service, Permafrost pilot service, focuses actually on providing information, especially to these two communities or user communities. So settlements and stations. how does it look like? So what we actually use is data sets of 20 years of trends from Landsat, from multispectral satellite data. And we condense this information that is contained in these 20 years of data at 30-meter resolution into one single map. And the single map is very colorful. And that's an example of what you see here, how we visualize permafrost landscape change with that data, which is usually very complex. And so we break it down into a very simple product that is made available through the Arctic Landscape Explorer that Tilman will introduce. And what we can see here, for example, is these reddish colors, new oil and gas infrastructure in Western Siberia, lake expansion and erosion around these blue margins of the lakes, increased wetting in some areas, but also drying or draining in these yellow areas, or even the new airport with red color. So this kind of data is available for the entire Arctic permafrost region. The new service providing these kind of disturbance maps. So we see especially strong changes. The gradual changes is a little bit more difficult to see here, but the strong changes show us that the Arctic is not a static environment, but it's a very dynamic environment, actually. So this helps communities to understand local risks better, hazards, but also landscape change, for infrastructure maintenance, but also future planning of infrastructures, and helps them monitoring regions. It's also important for us. Everybody's aware that only half of the Arctic is now available for access right now due to geopolitics. And this kind of tool helps us to keep an eye on regions that are not accessible on the ground at this point. Yeah, so where to find the data in different portals. They are available. So Tilman will introduce the APECS portal and its functionalities and the data set itself again. We have it also on the Google Earth Engine app, stored on Pangea, a World Data Center, as a data layer, but it's also available through the Arctic Permafrost Geospatial Center. The Permafrost Discovery Gateway is a gateway funded by NSF and Google in the US that uses that data set already. And we also have it available as a web map service, so everybody can include it in a potential other application or in their own desktop GIS system. With that, I'm coming basically to my last slide. So what's the relevance of this data set? This Permafrost service, basically, the change data set provides very interesting information also for several of the Arctic Council working groups. And so we identified a couple of working groups that could use this data set directly. So for example, the Arctic Contaminants Program, the Arctic Monitoring and Assessment Program, the Conservation for Arctic Flora and Fauna, CAF, and the Sustainable Development Working Group. And then also, I just had exchange with AMAP, that the AMAP CAF Joint Assessment of Climate Change Impacts on Arctic Ecosystems and Associated Feedbacks to Climate is going to be picked up again. So this has been dormant for a few years now, but they were very interested in also using that data set for their assessments. So many of the aspects of the changes in permafrost landscapes that we see in the field with remote sensing data are actually now also visible through this data set and the portal, and can be assessed not only by scientists, but also by anybody in communities, research stations, stakeholders, or other user groups that would like to see what is changing in the Arctic landscape. And with that, I would like to hand over to Tilman. Thank you.
Yes, thanks a lot, Guido. I hope you can see my screen all. Very good. Okay, so I am going to introduce to you a little bit more about the Arctic Landscape Explorer, or in short, the APECS tool. And I will do this in 3 steps. So first of all, we are using satellite data to detect disturbance trends in the Arctic that are associated with abrupt permafrost degradation. I will talk about this, and then we provide this data in maps that mark the different types of changes. We've already seen one map here. And then we come to the online tool, to the Arctic Landscape Explorer that visualizes the change data. Okay, let's get started with the Earth observation data. So we're using Landsat satellite imagery mosaics with a resolution of 30 meters. And that is very handy to do because they have a long track record of open access. So we can access this data for free. And this data has been around for many decades. We're using Landsat 5, 7, and 8 at the moment. And with the Landsat satellite system, we have a repeat circle of 16 days. So each place on Earth is being covered by a Landsat satellite within 16 days, and at even higher rates the further north you go. We are looking at a time series. So we are looking at change that happens during 20 years, the last 20 years. And here we are looking at the period between 2003 and 2022 at the moment. And we will regularly also update this cycle. We are covering the whole Arctic. You can see here in this map, everything that is marked in yellow colors is covered with our data. And we are using images mainly from July and August due to snow cover in other months. And we are selecting images that have a cloud cover of less than 80%. If you want to learn more how this data set is being created, I'm providing you here with a link to the entry in the Pangea database where all the details are given. Now, from the data to the trend analysis. So we are looking at disturbance trends or changes in the landscape that occur over time. And for this, we need to look at tens of thousands of images, many terabytes of data, and to automatically process all this data, my colleagues are using the Google Earth Engine, which is an application that is very well suited for large amounts of data. And I'm providing here the publications where this technique is being described. And it has also been part of many research projects already. And the approach is further refined and broadened. And now we have the Pan-Arctic coverage. With the trend analysis we are using regression models. And here we're using a very well-established one, the tile-zen regression. And also we are using a transform of the image. So we are not only looking at what you can see, the real colors, but we transform the image information into 3 parameters, which are brightness, and brightness is associated with changes in soil brightness. Greenness, which is related to changes in vegetation, and wetness, which is related to changes in surface wetness. So for these 3 parameters, we can see how the landscape is changing. And now there's a bit of a problem because we have a lot of information in our data and we want to visualize what type of change is happening in the landscape and to what magnitude. To find hotspots of changes, for example. And we've come up with this color triangle with opposing trends. So at the top in red colors, we have brighter surfaces opposed to non-brighter surfaces. We have wetter landscape, wetter surfaces in blue colors opposed to yellow colors. And we have an increase in vegetation, which can be seen in green colors. And the brighter the colors appear, the more flashy they are, the higher is the magnitude of change. Now, this is a little bit difficult to understand. We are aware of that, but we still think that this is the best way to do it. So in the next version of the APECS tool, which will be updated frequently, we have an interactive legend that explains these colors. So you can click on different spots here in this color triangle, on the color circle, and then you will find an example. Here for the red color, you can see as an example the Fort Knox gold mine in Alaska, which is an open pit gold mine. So you can see a lot of red color, meaning that this soil surface has become brighter. And the tool you can see on the top right, you can also choose to only display one of the 3 parameters. So either brightness, greenness, or wetness in 2 modes, in the dark mode and the light mode. Here in the light mode, only showing changes in brightness. You can see that these areas here are increasingly brighter. A few more examples for color meanings. We find a lot of lake drainages all over the Arctic, and they are depicted in yellow colors, as can be seen here in the Northern Seward Peninsula, sometimes also a bit more orange. We have a lot of fire scars we can see in our change data, for example, here in Central Yakutia. And depending on the succession stage, the colors look a bit different. but they also have very typical patterns. You can see them quite easily in the image. We already had the example of the Fort Knox gold mine, and of course, coastal erosion is another very important topic. And here at Drew Point in northern Alaska, you can see that a lot of coastal erosion is happening, and this is depicted in blue, dark blue colors. You can also see other man-made changes here on the other example, where we can see the construction of new roads. We can see activities of housing, and we have another gravel mine here. And sometimes all of this is happening in close location to each other, like in this example of Point Lay. That's a small community in northwestern Alaska. And here to the right, we have the freshwater, or the former freshwater lake of Point Lay, which has been drained into the river. We can see two lakes here that are growing in size, and we can see that at the coast, there's coastal erosion happening. And the barrier island that is here, we can see that that is also migrating. Okay, I have two more examples. Let's go to Cape Lawson on the Seward Peninsula, where we have quite high rates of coastal erosion. They are roughly around 5 to 10 meters per year. And in exactly this area, there are plans to construct a new shipping hub for the city of Kotzebue that is nearby on the Seward Peninsula. And if you look at this data, it becomes quite obvious that this is quite a difficult thing to build a shipping hub there. I have here the former shoreline on an image from our RV flight campaign back in 21. And yeah, I think you can see how drastically the shoreline has eroded over the last 20 years. The second example comes from Hooper Bay. And here you can see the airport that has been improved during 2015 to 17. The airport has been remodeled. You can see that in red colors. You can also see coastal dynamics. In this case, we have a lot of accumulation of sand, and near the shore, we have an increase in vegetation. Okay, now let's come to the Arctic Landscape Explorer. The aim of this tool is to provide an easy-to-use map service that shows and explains all these permafrost landscape changes. And we've chosen for this to have a website, a web-based tool that is accessible via browser on PC, laptop, tablet, and also on smartphone. And the technique behind this system is using standards like the web mapping service, which then also allows to use this data in other applications very easily. We optimized the tool for fast loading time, so even if you have low bandwidth, you can still, to some extent, use the tool and see the data. While you can see and have a look at the all of the Arctic, so you get a pan-Arctic view, you can at the same time also zoom in as far as you like to get a local view, so to get an idea what is happening near the village, the home, cabin, campsite, or a research station. What we've also implemented in the APECS tool are story maps. So I think this is a very nice way to bring across information about change processes. And our information is scientifically sound, but also we take an eye on having it very easily understandable. So we're using easy language and so on. There are a lot of map interactions in our story maps also. So you are learning how to handle the tool a little bit better in this way. And also we think that this can stimulate the user to explore changes on his or her own. We work with a lot of multimedia elements. So we have photos, we have videos, we link other satellite images. We have links to Google Street View so that you see from different types of information how they are depicted and how they are showing the changes. Okay, this is a screenshot of the APECS tool. We will have a live demo afterwards, so I'm not going to tell too much at the moment. But you have two parts of the screen. On the left-hand side, you have the map component, and on the right-hand side, you have additional information. And here's also where the story maps go. Yeah, and I will show you in a second more about this. So we had also consultations with local communities during field studies in Western Alaska in 22 and 23. We consulted various stakeholders in the cities of Nome and Kotzebue in Western Alaska. At that time, the tour was not live yet, but we had an early version of the tour that we presented, and we also brought with us some posters that showed the change on a local level and explained what you can see in the data. I think overall we received a lot of positive feedback, and we also together developed some ideas on how to use this data, how to use the tool, what it can be useful for. And since the release in late January this year, we also had requests from 3 government and tribal entities from Alaska and Canada to reuse our data service in their own products. So this was, of course, also very good feedback we received. Okay, so I will start the live demo now. You're also all invited to do your own tryout, of course. We have the link provided here, alex.awi.e. You have a QR code here that you can use. And there's one thing I want to highlight and want to ask you, because we prepared a survey on the APECS tool, which has gone live a few minutes ago. And you're very welcome to fill out this survey. It doesn't have to be now, but maybe after the seminar. I would be very happy if a lot of you could fill out this survey for us. I think we will also provide the link in the chat. But now let's go to the live demo. Can you see my screen now? Is it updated? Good. Okay, so this is the APECS tool. I increased the size a bit. When you open it, and here on the left, you have some basic map tools. You can zoom in, zoom out. You can do that, of course, also with the scroll wheel if you have a mouse, or on the smartphone as you are used with your fingers. You can enter a full screen mode, which is sometimes nice if you want to show something to someone else on your smartphone. And we have a feature here that leads you to your current place. So that's then easier for orientation. Now my computer thinks I'm in Bremerhaven because I'm logged in via VPN. I'm in Potsdam actually, but the network is in Bremerhaven. So this works also quite nicely. And if you want to measure something, let's go back to our Cape Blossom example here. We have a measurement tool here. So for a very rough estimate, you can like click here in the image and see, okay, how far has the coast eroded? And this is about like 130, 150 meters in the last 20 years. You have an information button here that shows you more information about the data that is currently being displayed in the map. You have a here you have a link to Google Maps. So if you want to see this extent of your map in Google Maps, you can click here, and then you zoom to the same location in Google Maps. You can change the background of your of the map application. So now we are showing the change data, but we can also, for our orientation, here choose to display a topographic map, and we also have satellite images here that you can use to navigate and to see what's happening on ground. And for Alaska, we also have another satellite image product, which is called Very High Resolution Alaska, but this is only for Alaska. Now let's get back to our change map. This button here that opens the legend I've shown you before, just for orientation. And this is also where you can switch between different modes if you want to display the changes in wetness, for example. Then you can choose here and switch the modes. Right, so I want to show you 2 more pages here. We have an about page where you can find some background information and a link to Arctic Passion projects and some acknowledgements. And at the bottom, we have release notes. So every now and then we have a new release of the APECS tool, and then you find information here on what has been changed and what is new. We also have a data section. So if you want to reuse some of the data or want to find out more about it, you can go to this page. And for example, we have links to the metadata, to our web service, and to references and how to cite the data. This might be useful for you as well. Okay, here's the section for our story maps. At the moment, we have one story map on thermokarst lakes, but another one on shore erosion is being prepared, and we will also soon publish the second story map on shore erosion. So if you click here on start, you're guided, like in the story map, through the story of thermokarst lakes. You learn how lakes are shaping the Arctic permafrost landscapes, and we have some example areas where we have a lot of lakes. We also have some diagrams where you can see that lakes are there are much more lakes in the Arctic region than in the other region in the world, and so on. So I invite you, like after this presentation, to go through the story map yourself and find out and explore some things. And if you have some feedback for us, we're always welcome to have feedback, of course. The last thing we've recently included also here in the tool is like a more local view. So we had been in contact with the Chiva community, and this meeting has not taken place yet, unfortunately, but we prepared for this meeting where we pinpoint some areas that we found where maybe some interesting changes are happening. And you can see this legend here. So we are marking coastal dynamics like erosion or accumulation, river dynamics, lakes changes, changes in vegetation, and so on. And then you can also click on them. And we have a very short description of what we think is changing here. And yeah, this would be one way to discuss with communities how they see what changes are happening and how we can see that in our data. Okay, I think I'm right in time. That was about my demo. I do have a very short sneak preview of some future things that we are developing. Do we have the time, or should I save it for later?
Maybe let's go for first. Yeah, I would like to ask around for questions first, because
Sure.
we know that Guido will leave us in 10 minutes. So you want to give the audience a chance to also ask questions to him. So it's really good. I think it would be nice to get the preview, but also let's discuss a little bit. So please get ready to ask your questions in the chat, which is now open. I'm sorry that it was disabled earlier, or in the FAQ box. Meanwhile, I would like to mention, while you're thinking and while you're typing, I would like to mention that the audience survey actually resulted in that we have more than almost 3/4 of our audience from early career stage. It's great that you're here with us, and most of them, actually 90%, are from natural sciences in the background. So there's quite some tendency here, and most of them, almost 70%, working in the Arctic and not living in the Arctic. So I think, yeah, we have quite some majority of early career natural scientists working in the Arctic. So please, yeah, ask questions. I actually have another survey which I will start now, which is actually asking you also a bit on your on your interest in the APECS web tool. Maybe you've can already state. Wait. Oh, this doesn't work. Well, then maybe you want to type in the chat whether your interest is more like of scientific background. I think that's what you can see already in the statistics, or whether it's more a curiosity thing, which you like to explore different regions with the tool, or did you actually see communities being affected and think that this tool would be of help here. And with this, I would also like to share the questionnaire, the survey Tilman was mentioning, just now online, available. And that would be really great to get your response here. So I don't see any raised hands so far, but that's your opportunity, so please do so. They give you permission to speak up. And also in the FAQ, there's no question, but there's one in the chat. What is the time period the maps are presented for on the website? Is it 23-22? 2003 and to 2022?
Yeah, that's absolutely correct. Yeah, and we've already had an update, but I think we'll soon also have another update. Then for 2020, from 2004 to 23, and then at the end of next year, again another update, so that we are keeping up with time. But as we are looking at 20 years of changes, from one year to the other, there will not be such an immense change in the data.
Mm-hmm. And Helena's asking, sorry, Guido?
It looks like now we have some questions here.
Yeah. So Helena's asking how this tool can be useful when communicating and co-creating knowledge in Arctic communities. Is it possible to pinpoint on the map and add what issues the local communities think is going on or find most important?
Yeah, so maybe Tilman can answer. And in general, the first answer, or general answer, is it does not work yet, but that's definitely a way we would like to go, because that's where both sides practically generate the most additional value for everybody. Communities can use it directly and pinpoint the changes they know about, the experience. And so we as scientists can also have more insight into what is actually happening in these regions, across the region. Maybe Tilman can say something on the technical side.
Yeah, exactly. So we have like a first start of doing that, where we as the scientists pinpointed a location that we think are interesting, and that would be the next step, that also other users can pinpoint out areas, and yeah, we can have a sort of discussion that is spatially in this way. Yeah, we're definitely going to look into that later, but it's not so easy, because if the user inputs something to the map, then there's security issues and so on.
Mm-hmm. So there's a question whether it's also working for East Canada.
Sure.
I think it's Pan-Arctic, right? So
it's Pan-Arctic. Yeah. We have included the whole of Canada and the whole of Alaska in that region.
Great. There's a question from Tetsu in the FAQ. Do you have any outlook on how long the APECS system will be maintained? So, with project results, it's also very important to think about the sustainability of the results. So what are your plans here?
Yeah, so generally that's always an issue, that projects end and then suddenly a portal doesn't work anymore. And I think for us, it hopefully will be very different, because so we have a long-term commitment from AWI to continue that work. So we have a strong interest, because from our experience over the last 2-3 years working with this tool and developing it, and working with communities also and seeing their interest, it makes it clear that this is a very valuable tool, not just for scientists, but also for the non-scientists. So it's a perfect example, in my view at least, how these two sides of the medal can be brought together. And so we definitely would like to continue this, and yeah, we have at least some means to do that.
Great. We have a question on the high latitude islands. They appear particularly bright in the change map. Can you comment on what's happening there?
Yeah, maybe I can also comment on this. So it's very difficult, and so the Landsat data is optical data. So it's very relying on cloud-free, snow-free data sets. In the farther north we go, the difficult it gets to have this kind of data every year over the 20-year period. So there are more and more gaps in between, and the data becomes a little bit more challenging to work with. And the trends actually that are based on a large number of samples in every year, or at least every single year over the 20-year period, if it becomes more spotty, then the trends become a little bit more uncertain. This is the case mostly for the high Arctic islands, also the case for areas near glaciers, for example, where there's more challenges with clouds and things like that, and snow. So around these areas, it's a little bit more challenging also to interpret the trend compared to other sites that are away from glaciers and islands.
Great. Guido, do you want to pick a question from the chat before you are leaving us, which is and yeah, just for you. It's really great seeing so many questions coming in. You can also raise your hand if you want to speak yourself.
There's one question from Tara, whether Sentinel data is included already. So that's actually not the case. So it's at this point purely based on Landsat 30-meter data, and that's so when we started developing it, the Sentinel data was not available for a long time period yet. So by now there are harmonized data sets for Landsat and Sentinel, and so that's definitely something that we would like to take into account for future updates of the data set. So basically combining the two, Landsat and Sentinel, increases the data density over the Arctic regions especially, and so that's something that we have in our view basically to do.
And does it also to capture mass movement as a consequence for permafrost thaw?
It does capture mass movements as long as they express also as surface changes. So we need to see changes in wetness or vegetation, bare ground showing up suddenly, things like erosion. Then we would see the mass movement. So one example is thaw slumps. They are very big. We can see them. Smaller thaw slumps is difficult because of the resolution, 30 meters. But large thaw slumps like the Batagai thaw slump in Siberia or on the Peel River Plateau, the very large mega slumps, these are fairly easy to see in the data set. Other types of mass movements, let's say rock glaciers or debris flows, that's a little bit more challenging because the surface changes are not as well expressed in these kind of features.
And there's an interesting question about the future. Is it also possible to show future landscape change?
Points towards modeling. That definitely would be very interesting, to combine this data set of the past with approaches how to predict this or project this into the future. Of course, many of the changes that we actually see are disturbances, which are to some extent also statistically random in the landscape. So it's a little bit harder to predict, I guess. Of course, they are associated with certain settings very often. So a thaw storm can only form where we have ice-rich ground. Lake drainage can only drain where a lake is before. So things like that could be potentially predicted. And we could use erosion rates of lakes or coasts, for example, to project where we might see a future coastline or shoreline based on linear extrapolation. But we are not there yet. So there's a big challenge for the modeling community to actually incorporate some of these very rapid and small scale processes, which are, however, widespread in the landscape. But that's something that's, would be the big prize in the future for the scientists to actually manage it.
Right. I think with this future vision, we let you go, Guido. I'm gonna discuss it a bit more and also let Tilman show his potential updates.
Okay,
Thank
great.
you
Thank
for
you
being us with us today.
Being online here, and thanks for the opportunity to present the project. And please continue.
Thanks, Guido. See you soon.
Bye.
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 Okay, but don't stop bringing up your questions. I think it's great to see a lot of interest here.
Yeah, there was
And
a question. Sorry, there was a question on if we plan to do classification of the change signals. This is interesting. We've thought about it, but we would need to look into that in detail, how well this classification would work. But it would very much help us also to pinpoint areas of like hotspots or areas which are very clearly changing. So that would be an interesting thing to look at. something like that. And then the same question also, why we not include what types of changes are associated with each color family in the color view. Yeah, that's something that's a good idea. We thought about that, and that could go to this interactive legends explaining tool also. Yeah, it's always a question how much space you have then.
Mhm.
But yeah.
Cool. One question I can answer is that there will be a recording of this meeting today, and it will be after some editing available on the APECS and APECS websites. Okay, let's go back to your questions. Actually, I'm gonna post the link to the tool once more because it may have been moved up the list, and also we would like to have your response to the survey. So this would be really helpful for the team. And since you will be the very first ones being able to respond, that would be really great to have your opinion in it. But do you want to say something about the survey once again, or advertise it a bit more?
Yeah, so please fill it out. No, that's part of the APECS project also to evaluate the value and how are people using the pilot services or the services. Yeah, so that for project work, that would be very good to have many replies, but also, of course, for us to see at what where we can work more and what you're interested in. And I've already seen in the chat that the pinpointing future possibilities would be something that is liked. Yeah, great.
So I'm going through the chat again, but I think we have covered most questions. If not, please resend it. And then look at my own question. Maybe you want to post the DOI for the database again, because this was in your presentations.
Okay, sure.
It'd be great so that people can look at the database. Okay. So this is still your chance to raise your comment or your question. We have very nice comments also, praising the effort. That was really nice of you. That's really great to yeah, it's great to see this good response. You only sent the link to me, Timon, but I sent it to all again. So yeah, please have a look. Thanks, yeah, for the very nice responses here. I also agree. I think it's a really it's a really great tool, and not only visually appealing, but also like great to be able to browse through the Arctic and actually see change happening. Yeah, really great effort. Okay, so it seems like.
You want me to just briefly show, give
Right.
this outlook?
Yeah, I think we will take the time. I think it's worth it. But no worries if someone needs to drop out. We are now reaching the hour of our webinar, but now comes a little bit of an outlook before we close it.
Okay, can you see my screen?
Yes.
Good. So yeah, it's just a very quick outlook of what we are planning on releasing soon. And we have like a non-public development environment for the tool. So you can't see this, but I'm showing it to you now live. So one thing I think is important, we need better orientation on the map. So we've already included here like places and place names, but we're still looking for another data set that covers all our area. So yeah, we will probably change the data behind it, but this is something that should come also soon. And I hope there soon will also be the Arctic digital elevation model available so that you can see height information. And I'm in contact with the developers, and they said they are going to provide a service that I can include in the future. the one I have here now is not meant to be included here. So yeah, on our start page, we will also have some updates. So we will have like mini story maps in itself here for interesting places where the user can just have get a first idea on what is happening here. For example, in True Point, you can start here in Overfly that is linked where the plane is flying across the shore and it's loading. Okay, and yeah, you can go to other places where you have a little bit of explanation and then also some explanation in the colors. And yeah, as I said here, we have the interactive legends, and yes, we think about having also some text here that explains. Oh yeah, and one thing that we will also make possible is to easily share links to a certain view of the map. So if you want to tell a colleague, okay, look at this structure here, that's something I'd like to show you, then you can just copy the link from the URL, and if I then press enter, then you will be directly in the same area. It's not working now, but soon. And then we will also have some functionality to more easily overlay the satellite image and the change map, that you can see what landscape is below that. So by swiping or fading. Yeah, I think that's what is planned for now.
Cool. Thanks for giving the preview. A very special preview here. There are, I think, at least 2 more questions. One is about the data it presents itself. So is it possible to download data sets, time series, for time series analysis, for example?
Well, you can download the whole data set if you want to analyze it further. And we also have the data set available in Google Earth Engine if you want to calculate with the data. We are also planning on like a functionality where you can actually see a time plot. So how is the landscape changed within those 20 years? But this is a little bit complicated and requires a lot of computation in the background. Yeah, so we keep this for future updates.
Nice. That is always more to include, I guess.
Yeah.
Great. All right. Unless you have any more questions, I look at my own questions, but I think actually most of them have been raised anyways. This is your last chance. Some have to leave already. That's totally fine, of course. All right. Then I think we can close our today's APECS online seminar and discussion series. This recording will be available afterwards, with a few editing. And I would like to thank Tilman so much and Guido in his absence for being able to present today. I think it's really good timing now that we have also, yeah, we have so many, yeah, I think important things to learn about the Arctic, and also being able to share this to a wider audience and making it visual. It's very important, and I think you did a great effort in also sharing with communities, and I think this is, yeah, on a very good way to make this tool available for the important audience for us in the Arctic. And yeah, thank you for all your thank you notes. It's very kind of you. And yeah, we hope to see you again for one of our next online seminars. Keep your eyes open in Arctic Fishing and on our social media channels and newsletters and websites. And with this, I would like to close for today. Thank you everyone for joining.
Yes, thanks for having us. It was great, and thank you for your questions. Very inspiring.
Yeah. Bye bye. Thank you.
Bye.